Welcome to finding higher order derivatives implicitly. Let's just go ahead and jump straight in with an example. Find y double prime, or the second derivative of y, if x squared plus y squared equals 4. So just like usual, when we want higher order derivatives, we have to start by finding the first derivative. So we're going to first find y prime, which we actually did this earlier in another video, but we can do it again. So we are going to differentiate with respect to x, both sides. So we have derivative of x squared plus y squared, taking the derivative with respect to x is equal to the derivative with respect to x of 4. On the left-hand side, the derivative of x squared becomes 2x. And the derivative of y squared with respect to x, we do with respect to y first. So that's 2y. And then multiply by the derivative of y with respect to x. There's our chain rule. On the right side, derivative of 4 is just 0. And if we rearrange this, we had 2y times dy dx is equal to negative 2x. Or dy dx is equal to negative x over y. So now we're going to differentiate this again. Now we'll find y double prime, or d squared y dx squared. So we're going to differentiate again. So we take the derivative with respect to x of dy dx, and then on the right, the derivative with respect to x of our negative x over y. So we have the derivative with respect to x of dy dx is equal to the derivative with respect to x of negative x over y. We have d squared y dx is equal to, this is a quotient rule problem. So again, the quotient rule, we can keep that negative out front. And then the quotient rule says we do the derivative of the first. So the derivative of x times the second times y minus the first x times the derivative of the second, so times y, and then all of that over the second squared, so all over y squared. This becomes negative, and then up top, derivative of x is just 1, so we have y minus x times derivative of y is just dy dx, all over y squared. And then, so we have d squared y over dx, oops, I forgot my squared earlier, over dx squared is equal to negative y minus x times dy dx over y squared. At this point, we're going to plug back in the fact that we know dy dx is equal to negative x over y. So we have d squared y over dx squared, otherwise known as y double prime, is equal to negative y minus x times negative x over y, all over y squared. Or this is equal to negative y plus x squared over y all over y squared. Or this is equal to negative y squared plus x squared all over y cubed. So we have y double prime is equal to negative y squared plus x squared, or x squared plus y squared all over y cubed. And technically, we started off the problem with x squared plus y squared equals 4. So we could, if we wanted to, just recall, note that x squared plus y squared was equal to 4. And so we could just say that we actually have y double prime is equal to negative 4 over y cubed if we wished. So again, this is finding the second derivative. And we essentially took advantage during this process that we know dy dx in terms of x and y. So when we ultimately found another dy dx inside of our second derivative, we could substitute back in to get back to just x and y.